Allow me to start the lecture discussion. For this afternoon, we will discuss all about organic reactions. Particularly, I will be discussing later on the specific types of chemical reactions that hydrocarbons undergo. But before that, let me give you the general concepts on the mechanism of chemical reaction that occurs among organic compounds. These are polar type of reactions. I have mentioned this in our laboratory last meeting. Polar reaction, this is the most common type mechanism of reaction that occurs among hydrocarbons, among organic compounds specifically. So in this reaction, it only involves electrical attraction between a positive polarized atom and a negatively polarized atom in a molecule. So purely, you have here an electron pour. Let's say you have an electron pour being reacted to an electron-rich atom. Now, for you to understand, the how these reactions take place, you have to first recall the concept related to polar covalent bond. So recall natin, polar covalent bond, to classify them, uh, we have to know what is the characteristic of the polar covalent bond itself. Recall that in a polar covalent bond, there is unequal sharing of electrons, unequal sharing of electrons. This happens because there is an observable presence of electronegative, highly electronegative atom. What are examples of highly electronegative atom? We have, for example, the most common, oxygen. Okay, so for instance, you have a carbon bonded to oxygen. Since oxygen is highly electronegative, it would pull more of the electrons towards itself. That's why oxygen will now carry partially negative uh, sign, and carbon here will carry a partially positive pole. Okay, so this covalent bond here is a type of polar covalent bond because there is an unequal sharing of electrons. Now, the same polarity pattern can be observed among bonds in hydrocarbon derivatives, or those functional groups with with the presence of oxygen. Presence of oxygen. So example, alcohol. Alcohol contains this functional group, an OH. And as you can see, a carbon here is bonded to an oxygen. Therefore, polarity pattern is observed here, wherein oxygen will carry a partially negative sign and carbon carries a partially positive sign. So the rest of the given, ayan, representation of functional group among hydrocarbon derivatives, since they all contain oxygen here, oxygen, oxygen, you can observe a polarity pattern among these bonded atoms. So just take note, oxygen, since this is highly electronegative, it will carry partially negative pole. Okay, so partially negative, negative. Whereas carbon, siya naman yung partially positive. Okay? Now, try to identify the functional group. COC, ROR, diba, that is ether. RCOOH, yan naman yung, recall lang niya siya ha, recall, carboxylic acid. RCOOR, that is ester. Then RCHO, this is aldehyde. And then finally, ketone, RCOR. So again, oxygen here will carry partially negative pole, carbon partially positive pole. Okay. Okay. Now, of course, we have exceptions on the polarity pattern being observed among functional group. There are functional group wherein non-polar naman yung observed sa kanilang functional group. Example, for alkenes. Alkenes functional group is double bond carbon to carbon. For alkynes, it's triple bond carbon to carbon. So if identical atoms are bonded together, that covalent bond is identified as non-polar covalent bond. So non-polar. Covalent bond kapag identical, di ba? Yung atoms being bonded. Now recalling, I have mentioned this also in our laboratory. If there are presence of multiple bonds, halimbawa in alkenes, alkynes, we describe that functional group of hydrocarbons as electron rich, rich in electrons. Because in a bond, electrons are shared. In a bond, electrons are shared. We're talking about covalent bonds where there is an observable sharing of electrons. So sa isang bond, that's equivalent to 2. Sa isang bond, equivalent to 2 electrons. So meaning to say kapag multiple bonds yung present, halimbawa sa alkenes at saka sa alkynes, then we consider that part of their molecule as electron rich in electrons. I've mentioned that in our lab. Now let's try to relate the functional group polarity pattern being observed. How does it affect chemical reactivity? Ito na discuss ko na rin sa laboratory kaya faster yung pacing natin. Recalling, you have an electron-rich atom and you have an electron-poor atom. For a polar reaction to proceed, the electron-rich atom will simply donate electrons to the electron-poor, thus forming a bond. So itong bond na to, forming the product AB, the bond is formed or made possible when an electron-rich atom donates a pair of electrons to an electron-poor. And I've told you that we have certain terms describing an electron-rich species versus an electron-poor species. Naalala yung nucleophile and electrophile. Okay? So yung nucleophile, based sa term, this is also considered nucleus loving. Na-mention ko naman to, di ba, sa laboratory. Electrophile, ito naman electron loving. Okay? Therefore, if nucleophile is nucleus loving, this is said to be electron rich. Siya yung electron rich. Okay? Kasi naa-attract siya doon sa positive charge. Na-attract siya doon sa positive charge. Ano ba yung meron sa kanya? Mas marami sa kanya. Mas marami sa kanya negative. Okay? Negative charges, or we described it as negatively polarized atom. Okay? Kasi opposite attracts kapag polar reaction. You should have a positive pole and then a negative pole. If ang nucleophile is being attracted to positively charged na mga atoms, then yung characteristic niya mismo is negative. Kung siya yung negative, syempre maa-attract siya doon sa positive, sa nucleus. Okay? Now, to form a bond, yung gagawin lang ng mga electron-rich is simply donate pair of electrons. So it can, kindly take note, it can form a bond by donating a pair of electrons. Saan niya idodonate? Idodonate niya to the electron poor. Okay, to a positively polarized, okay, electron poor. So yan po yung characteristic ng nucleophile. So ano yung na-discuss dito na mga descriptions ng nucleophile, i-antonyms lang natin sa kabilang side. I-antonyms lang natin sa kabilang side. By the way, kindly highlight, ayan, this part, donating a pair of electrons. Now, because nucleophile has this characteristic, we could consider then that nucleophile also acts as base. They also acts as base. Kasi kapag base, they are electron pair donor. Okay? Pero kapag naman proton yung pinag-uusapan, sila naman yung proton acceptor. So that's a characteristic of a base. So sinabi man dito, ang nucleophile daw, they are able to donate a pair of electrons, then they are donors of electron pair. Kapag capable ang isang atom mag-donate ng electron pair, it is also consequently able to accept proton. So that's the characteristic of a base or characteristic din ng nucleophile. Sige, proceed with electrophile. So kung ang electrophile are being attracted to electrons, electrons are negative. Electrons are negatively charged. Therefore, we could describe the characteristic of electrophile as electron poor. Sila yung poor of electrons. Kaya naa-attract sila sa atom na marami. Marami ang electrons. So, electron poor meaning positively naman sila. Positively polarized. Polarized atom. Okay? And for them to form a bond, they can form a bond by accepting pair of electrons. Bond by accepting. I-antonyms lang yung mga statement na nasa left side. Okay? Accepting pair of electrons. So, saan ba nila i-accept? Saan ba galing yung pair of electrons na i-accept nila? From a negatively polarized electron rich. Electron rich. So, that's it for electrophile. So, kung ang nucleophile is a base, then ang mga electrophile acts as acids. Okay? So, acids, take note, they are electron pair acceptor. Sabi dito, they accept pair of electrons. That is also a characteristic of any acids. And talking about proton, ano ba yung ginagawa ng mga acids in terms of proton? Kaya nilang mag-donate. So, proton donor naman sila. Talking about proton, magkaiba yung electron sa proton. You know that, na magkaiba yung electron sa proton. Okay? So, yan po yung kaibahan ng electrophile and nucleophile. I've introduced this already sa lab, sa laboratory. So, it's not a problem anymore. So, this is just a review. Now, we have certain compounds that are considered neutral, meaning to say they can often react as nucleophile or as electrophile depending on the circumstances. For example, water. Di ba yung water, when we draw its Lewis structure, this is how we draw its Lewis structure. Okay? So I mentioned that it may act as electrophile, or in some instances, it may also act as nucleophile. So when will water act as electrophile or as an acid? Kailan naman siya mag-act as nucleophile or as a base? Okay, water. Water has a source of proton. If in that reaction, water donates proton, water donates proton, then in that instance, in that reaction, it acts as electrophile. Okay, when it donates proton, electrophile siya on that state. Now, tingnan yung highlighted na non-bonding electrons. Di ba? Meron siyang dalawang pair of lone electrons. If in case sa reaction, ang water donates that non-bonding electron, if it donates a pair of non-bonding electrons, then it acts as a nucleophile. Kasi sabi natin kapag nucleophile, it donates a pair of electrons. It donates a pair of electrons. Then, nucleophile siya on that state. Okay? Other examples, yung mga carbonyl containing na compounds. Diba? That is carbonyl. Carbonyl, kapag ang carbon doubly bonded with oxygen, yan yung carbonyl. Okay. Now, based sa polarity pattern being observed, a carbon is bonded to oxygen. Which do you think will carry partially positive pole? Is it carbon or oxygen? Carbon or oxygen? Sino kaya yung magki-carry ng partially positive pole? Base sa na-discuss natin sa previous notes. Your only answer is either carbon or oxygen. Sino kaya yung magki-carry ng partially positive pole? Okay, very good. It's carbon, partially positive pole. Whereas oxygen will carry partially negative pole. Okay, that's based on the polarity pattern. So when will be the carbonyl compound acts as electrophile kapag ang reaction nangyari sa carbon atom. Kasi sabi natin electrophile, positively polarized atom ang isang electrophile. Therefore, if the reaction happens at its positively polarized carbon atom, then it acts as electrophile. Kapag naman nucleophile, magiging nucleophile yung action niya or role niya in the chemical reaction, si carbonyl, if yung reaction naman nangyari sa oxygen, sa negatively polarized oxygen. So if it reacts at its negatively polarized oxygen atom. So yun naman, at that state, carbonyl compound acts as nucleophile. So my point here is there are compounds that may act either as nucleophile or as electrophile. Example, water or carbonyl compounds. Okay? So that's the general concept about polar reactions and the terms nucleophile, electrophile. Now at this juncture, let me discuss the specific type of reactions that occurs among hydrocarbons, starting with alkanes. I've mentioned this also in our laboratory. That's why faster yung pacing natin for this topic. Okay, so recall, alkanes functional group is carbon single bond to carbon. So single bond carbon to carbon or single bond carbon to hydrogen. The same similar groups of atoms bonded together being observed in all other organic molecules. Makikita din ito sa lahat ng mga organic molecules, yung single bond, carbon to carbon or single bond carbon to hydrogen. That is why alkanes are considered less reactive. Kaya sa mga chemical reactions, konti lang yung idadiscuss natin na reactions under alkanes. And the most commonly encountered reactions among alkanes are combustion type of reaction. So this This same chemical reaction occurs among other hydrocarbon atoms. Okay? So lahat ng hydrocarbon atoms, mapa-alkanes, alkenes, alkynes, aromatic compounds, they undergo combustion type of reaction. Okay? And in a combustion type of reaction, the reactant being added to the hydrocarbon is the oxygen molecule. Okay, so let me give you the general reaction in a combustion reaction. Let's say we have any alkanes given. So any alkanes, mapa straight chain alkanes, branch chain alkanes. So any alkanes given, and then it is being reacted with an oxygen molecule. Now there are two two different types of combustion reaction depending on the supply of oxygen molecule being reacted to the hydrocarbon. If it is s- uh, enough supply enough supply of oxygen, then complete combustion will proceed. And in complete combustion, the products are carbon dioxide and water. So you know that already. And kapag naman incomplete combustion, if there is deficient supply of oxygen being reacted to the hydrocarbon, then incomplete yung type of combustion. And visible result observed is the carbon soot, yung itim-itim. Kapag may itim-itim na natira sa mismong dish, let's say evaporating dish, if you conducted this in the laboratory, then that is an, an indicator that incomplete combustion proceeded. So yan po yung mga products ng incomplete combustion. Instead of carbon dioxide, it is replaced with carbon monoxide, which is a fatal gas, and carbon soot. Okay, so that's it for combustion. Pinaka-common yan na chemical reaction that alkanes undergo. Now, another type of chemical reaction that alkanes undergo is the halogenation. Although this is not that significant or pronounced or commonly encountered among alkanes, konti lang, pili lang, selected lang na mga alkanes ang nag-a-undergo ng halogenation. But if it happens, then it's predictable naman kung ano yung magiging product. Okay, so in halogenation, this occurs via the mechanism free radical substitution. Free radical substitution. So that's what happens in halogenation of alkanes. We're talking about alkanes. So let me give you the general reaction. What happens in halogenation? Okay. So obviously, what is being substituted, because we're talking about substitution mechanism, what is being substituted to one of the hydrogen found in carbon 1 of that alkane is a halogen. Halogen is the one that substitute the hydrogen found, one of the hydrogen found in carbon 1. Okay? So makikita mo sa reactant side, dito sa reactant side, bago yung arrow is halogen. And 'di ba when we write halogen, general formula ng halogen is capital X. And any halogen in nature or in the environment, it occurs as diatom, as diatomic molecule. Kaya makikita nyo, nilagyan ko siya ng subscript of 2. Yan yung stable form ng halogen in nature or in the environment as diatom, X2. Now, chemically speaking, ang pinaka-reactive halogens that reacts to hydrocarbons are chlorine gas and also bromine gas. Nilagyan ko ng greater than na sign favoring chlorine gas kasi kapag ni-rank yung based on reactivity, i-compare natin yung reactivity ng dalawa, more reactive yung chlorine gas. Okay? So, pwedeng sa halogenation reaction, pwedeng chlorine yung halogen being added or bromine yung halogen being added. Okay, going back to the halogenation reaction ng alkanes. In halogenation process, there is a need of a UV light, okay, or a high elevated. Sulat ko na lang dito, high or elevated temperature. So yung triangle represents application of heat, but it's at elevated, high temperature. There's an essential reason why we need UV light in the process because the UV light will cause breakage of the bond that connects the halogen. Di ba yung halogen dyan is 2, may subscript of 2. So isipin nyo, dalawang halogen yan being bonded. Let's say, chlorine, gas. So dalawang chlorine yan being bonded, kaya Cl2. Kapag sinabing bromine, gas, Br2, dalawang bromine yan being bonded. So yung gagawin lang po ng UV light is to break that bond within the halogen molecule para mabuo ang free radical. Remember when we describe a free radical, this is an atom with unpaired electron. So kapag binrake mo yung bond, each of the halogen will now carry unpaired, walang partner na electron kasi hiniwalay mo sila. Okay? So each of them will now become reactive. They will now become sort of free radical sila. Sila ngayon yung isa-substitute natin sa sinipa na hydrogen sa alkane. So kung isusulat ko yung product, this is how you write it. Diba? Ito yung merong hydrogen kanina. Itong kulay pula na bond. Ito yung may hydrogen kaya sinipa natin yung hydrogen kasi it will be substituted with halogen. Free radical substitution. So isa, itong kulay red, ayan, isang free radical dyan will be substituted here. Saan naman mapupunta itong other free radical? Dito naman siya katabi ng sinipa na hydrogen, yung sinubstitutan na hydrogen. Okay, so color, same color, ayan. Okay, so ito yung isa, ito naman yung isang halogen. This is the major product. Major product natin is isang alkyl halide. Okay, alkane group na merong halogen. That's how you predict product for any halogenation reaction of alkane. So let's say, for example, the given is the simplest ethane. No, simplest ethane compound. Ayan, so this is ethane kasi dalawa yung carbon. And let me specify a halogen added to it para yung reaction talaga is halogenation. So let's say chlorine gas yung inad ko. in the presence of UV light. So you know already what's the purpose of UV light. Gagawin niya lang, i-break yung bond within chlorine gas. Okay? So meron ka ng free radical, another free radical. Okay? So how will you write the product? So this is the product portion, no products. Yung sa kabila, yung before the arrow, yung nasa kaliwa, yun ng reactants. So how will you predict the products? Again, since this is substitution, ayan, substitution. Kailangan meron kang sisipain, okay? Then mag-replace ka, mag-substitute ka ng free radical. Okay? Ma'am, kung saan man namo pagkabalo nga siya ang amuang sipaon nga hydrogen. Again, look for the carbon number 1. Hanapin niyo yung carbon number 1 sa any alkane given in that chemical reaction. You know already how to identify which is carbon 1. Okay? Di ba after you, in naming, after you find the parent chain, you number it. You number it. Okay? So kung sino yung number 1, dun ka kukuha ng isa. Isa lang na hydrogen, sipain mo, then palitan mo ng halogen, kung ano yung given na halogen being added. Okay, so let me write the final product. Ayan, so hydrogen, hydrogen, papalitan ko yung isa. Let's say, this could be number 1, di ba? This could be my carbon number 1 in this given molecule. Pwede din yung isa, yung carbon 1. Parehas pa din yung magiging product. Okay, so I will write chlorine here, chloro. And then, yung sinipa na hydrogen, ito yon. Okay, then you provide the byproduct. This is the byproduct. Hydrogen chloride. Ito yung isang free radical, another free radical. So yung major product dito is 1-chloroethane or chloroethane. Okay? Which is an alkyl halide. So that's how you predict product in halogenation of alkanes. Okay, but again, this is not that significant type of chemical reaction that occurs among alkenes. Kasi limited lang yun nga number of alkanes ang pwedeng mag-positive result sa halogenation. Okay, but the most common type of reaction that alkenes undergo is combustion. So that's it for alkanes. Next, let's proceed to reactions of alkenes. Ayan. Recalling, alkenes have the functional group double bond, carbon to carbon. And because it is a higher functional group compared to alkanes, this is more reactive than alkanes. All right. Now, another characteristics of alkenes, diba? Since yung functional group niya is double bond, carbon to carbon. So may presence ng multiple bond. Take note that in this functional group of alkenes, we consider this as electron rich. Diba? Yun yung sabi natin. Kapag may multiple bond within carbon to carbon bond or carbon to carbon, like for alkenes or alkynes, may multiple bonds, then electron rich yung portion na yan. And what is the term we use to describe an electron rich atom? Diba? That is nucleophile. Therefore, that electron rich characteristic ng alkenes, they tend to react with electron poor. Kasi polar reaction man tayo, 'di ba, sa organic reactions. Ang electron rich ire-react siya sa electron poor. And how do we describe electron poor atom? Yun yung mga positively polarized atom. So sila yung electrophile. That is why sa atong last laboratory experiment, I highlighted that alkenes reaction, they commonly undergo electrophilic type of reaction. Electrophilic type of reaction. Kasi base sa characteristic ng alkene, electron-rich man siya. Nucleophile man yung mismong reactive site ng alkene. Knowing that that's the functional group of alkene. Diyan mangyayari yung chemical reaction. Kaya, being a nucleophile, ire-react siya sa electrophile. But what specific type of electrophilic reaction does alkenes undergo? Ano nga ulit yon? Is it substitution or addition? It is. So ano yung blank dito? Okay, very good. It's addition type of reaction. Electrophilic addition reaction. So take note of that. Alkenes, alkynes, they undergo electrophilic addition reaction. Now, why is it capable yung addition reaction among functional groups with multiple bonds? Halimbawa, kay alkenes or kay alkynes. So, ano ba yung characteristic meron sila? So, I repeat, sa alkenes, may double bond. Sa alkynes, merong triple bond. Okay, triple bond. So, parehas sila, may multiple bond. Parehas din sila, meron tayong tinatawag na pi bonds. Yung highlighted nga color black, yun yung pi bonds. Di ba sabi ko, na sa isang multiple bond, yung unang bond dyan, itong kulay red, yan yung sigma bond. Then the rest of the bonds sa isang multiple bond, the rest are considered pi bonds, yung kulay black. Pi bonds. Pi, ito yung spelling ng pi, no? Pi bonds. So kapag tinanong kayo sa double bond, 'di ba? Isa yung pi bond. Sa triple bond, ilan kaya yung pi bonds sa triple? Sa triple bond, ilan kaya yung pi bonds? There are two of them, no? Two pi bonds. And because of that, presence of pi bonds capable yung addition reaction sa kanila. Kasi compare natin yung strength ng sigma versus pi, relatively weaker ang mga pi bonds. Kapag weaker, then our realization, madali lang silang ma-break. Okay? So let's say, for instance, we have here, sorry. Let me draw representation of alkene. So this is an alkene. Merong double bond. Sabi ko nga, itong kulay pula, the second bond, is a pi bond. Since this is weaker bond compared to sigma bond, madali lang siyang masira, madali lang siyang ma-break. And that's the most important step, first step na dapat gawin in any addition reaction. Addition reaction will only proceed if we break the pi bond. Okay? So that's the first thing na mangyayari. So para ma-add itong electrophile na to, kailangan talagang sirain ang pi bond. So sa isang alkene, double bond man yan, so may isang pi bond. We have to break it. That's the first thing that you should do. General concept ito ha, na maa-apply sa lahat ng electrophilic addition reaction ng alkene. So break first the pi bond. And recalling Sa isang bond, let me change the color. Ayan. Sa isang bond, electrons are shared. Kapag sinira natin yung bond na yan, each of this carbon will now have unpaired electron. Meaning, unstable ngayon yung initially double bond carbons kasi sinira natin yung pi bond. Sisirain yung pi bond. And that makes each of the carbon highly reactive. And that will facilitate addition of electrophile. We can now add the electrophile kasi nasira na natin yung pi bond. It will now allow addition. You cannot or never add a particular entity, electrophile, to that portion ng molecule if wala kang sisirain nga bond. Okay? So, if I were to write the product, general product, di ba single bond na ngayon, mula sa double bond, we break it, etong unpaired electron meron sila, will now accept the electrophile being added. That's how electrophile addition reaction happens. So any specific type of electrophilic addition reaction uses this concept. Okay? So lagi niyong tandaan, if it is classified in this type of general reaction, ito po yung gagamitin na concept. Break first the pi bond so that each of the carbon will accept the added electrophile. Okay, and we have four types of electrophilic addition reaction that occurs among alkenes. One is what we call catalytic hydrogenation. By just understanding the name of the reaction itself, you can actually predict. You can predict what electrophile is being added. Sabi dito, hydrogenation. What do you think is the molecule being added? Hydrogenation. Kanina, halogenation. It's halogen. What do you think is the electrophile class being added if it is hydrogenation? Yes. Okay, so it's predictable based on the name itself. Kapag nabasa mo hydrogenation, then automatic. What is being added? Hydrogen gas. And you all know that hydrogen occurs in nature as diatom as well. Kaya may H2. May 2 na subscript. Okay? So diatom din siya. Para saan yung catalytic na word? Listen, any hydrogenation reaction requires a catalyst. Any hydrogenation reaction requires a catalyst. And you've heard about this term. A catalyst speeds up reaction. It supports the forward type of reaction. So yan yung lagi niyo lang tandaan na sa reactant, ang makikita namin na being added sa alkene is hydrogen. Tapos meron siyang kasama na catalyst. Metal catalyst to be specific. We have platinum or palladium or nickel, either of that three. Those are examples of metal catalyst na pwedeng gamitin during catalytic hydrogenation. Now, what will be the electrophile that will be added, that will be produced out of this reagent? Siyempre, yung inad mo, hydrogen gas, so you will have H, then another H. Kasi H2, dalawang H. So, isang hydrogen, i-add mo sa isang carbon, another hydrogen, i-add mo dun sa another carbon. So, let's say, we have here the general reaction for catalytic hydrogenation. So any alkene given, and I've mentioned, lahat ng reactions involving alkene, mangyayari lang po yung reaction sa mismong functional group niya. Wala ng iba. Okay? So hanapin nyo lang yung double bond sa given na alkene. Doon po mangyayari yung reaction. So in this given reactants, hydrogen gas with a metal catalyst, if you are to identify what type of reaction is this, then identify it as catalytic hydrogenation. Malalaman mo based sa kung anong inad. Nakita mo may hydrogen gas, then it's hydrogenation. Okay? Particularly, may catalyst man, a metal catalyst, so it's catalytic. That's the appropriate term, the complete name of the reaction. Catalytic hydrogenation. And ano nga ulit yung mapoproduce na electrophile? Tapos maa-add natin sa mismong double bond carbon. Those are isang H, another H electrophile. Okay? So first thing na mangyayari, yung concept na didiscuss ko kanina, Itong pi bond kulay red, you break it so that each of this carbon will now facilitate addition reaction. Kasi meron na silang unpaired electron. Kung meron na silang unpaired electron, tatanggap na sila na kung anumang electrophile na i-add sa kanila. Okay? And ano sabi natin kapag catalytic hydrogenation? Isang H sa kabilang carbon, isang H naman sa kabilang carbon. Yun yung electrophile na maa-add if it is catalytic hydrogenation. So that's it for catalytic hydrogenation. Okay? So let's say for example, the given alkene is ethene. Okay? Or ethylene. Now, for ethene, sabi dito, added is hydrogen gas and the catalyst is nickel. So, purely catalytic hydrogenation. So, isipin nyo agad, after i-break ko yung pi bond, ang maa-add is isang H, another H. Okay, isang H, another H. Pero saan ko siya i-add? You highlight the double bond. Hanapin nyo kahit gaano pa yan kalaki yung structure ng alkene, hanapin nyo lang po yung double bond. Doon lang po mangyayari yung changes sa molecule. Okay, doon lang mangyayari yung changes sa molecule. Then the rest of the part ng molecule, kopyahin nyo lang. Okay? So halimbawa, ethene has undergone hydrogenation. So break, ibang kulay na lang. We break the pi bond here. Okay, yung kulay blue. Kaya each of this carbon, meron ng unpaired electron. Okay? So it will now facilitate addition. So ito yung original, 'di ba may hydrogen na siya, tig-dalawa. Hydrogen tig-dalawa. Ito 'yon, yung original na tig-dalawa nilang hydrogen. Now since kailangan tayo mag-add kasi nag-break tayo ng pi bond, you add one more bond for each carbon to facilitate addition. Okay, to facilitate addition process. So you have hydrogen added on one carbon, then hydrogen on another carbon. So kopyahin nyo lang yung the rest of the parts. May changes lang talaga doon sa mismong reactive site. Purely adding hydrogen. Take note that this process is the same similar process used in the production or manufacturing of margarine. Okay, so this is just an additional information na kapag nag-manufacture pala ng margarine, ito yung ginagamit na process. Hydrogenation of unsaturated fatty acid. Kasi yung ginagamit nila na raw material, kailangan para magbuo ng margarine is an oil, a liquid. Okay? Usually a fixed oil. So it's unsaturated. unsaturated. So may presence of multiple bonds. And then via hydrogenation process, ano yung product, 'di ba? Alkane yung product, saturated. Saturated fatty acid yung product, which is now a solid form of fats. That's why margarine is solid yung characteristic niya. Okay? So take note of that. Generally speaking, any catalytic hydrogenation of alkenes, alkane yung final product. Okay, let's have another example. Ito. So erase ko lang ha. Basta hydrogenation tapos nickel catalyst daw. I need to write the uh, yung correct manner of writing chemical equation. So you have the formula of 2-hexene, condensed formula of 2-hexene given. Then sabi with hydrogen gas. So added daw siya with hydrogen gas in the presence of a nickel catalyst. Okay? So sabi ko nga kanina, kahit gaano pa kalaki yung given na formula, mapa-condensed or skeletal formula, mangyayari lang po talaga yung reaction sa functional group, sa double bond. Okay? So i-highlight nyo para hindi kayo mawala. So kopyahin nyo yung buong molecule, dito lang magkakaroon yung changes. Okay? So kopyahin natin. H3, CH2, CH2. O, ibahin ko yung kulay na may double bond para hindi mawala. CH, tapos, supposedly from double bond, di ba sa product, i-break natin yung pi bond. Kaya, upon breaking this bond, single bond na sa product side. So, CH, then CH3. Okay, so single bond na ngayon. After we break the pi bond, each of this carbon may unpaired electron. Kasi nag-break tayo ng pi bond. So, tig-iisa sila merong unpaired electron mula sa na-break na bond. Ano yung gagawin nila para ma-stabilize? This is hydrogenation. Add ka, tig-iisa, hydrogen, then sa kabila din, hydrogen. Add ka dito ng isang hydrogen, dito din isa pang hydrogen. So, tingnan natin. From CH, kung mag-a-add ka ng isa pang hydrogen dyan na carbon, that will become CH2. Tama. From CH, mag-add man kag-isa ka hydrogen kasi addition of hydrogen ito. CH2. Ito din. From this carbon nga, isa lang yung hydrogen, mag-a-add ka 'di ba ng one more hydrogen kasi it has unpaired electron kanina after we break the pi bond. So, lagyan mo lang ng CH2. Kaya from 2-hexene, the product is now hexane. Hexane. Okay? So, alkane ang product. Okay? Sige. So, another. 1, 2, 3. This is 3-heptene. Okay? 1, 2, 3, 4, 5, 6, 7. 3-heptene yung given. It is added with hydrogen gas. So, yung ma-extract natin na electrophile that will be added sa reactive site ng alkene, isang hydrogen, another hydrogen. Okay? So, kopyahin nyo yung buong molecule. 1, 2, 3, 4, 5, 6, 7. Okay? Then, di ba, itong portion na ito, yung merong double bond. Siyempre, i-break naman natin yung double bond, so single bond na lang. Okay? Ayan, single bond. It's okay na upon adding the hydrogen, talagang ilalagay nyo siya para visible siya. But since this is skeletal formula, naalala kapag skeletal formula, merong atom na imaginary. Lahat ng hydrogen, imaginary lang po. kapag skeletal formula. That's why after you break the pi bond, it's okay na hindi mo na ipakita yung inad na hydrogen. Kasi automatic when we break the pi bond, if it is in skeletal formula, meron na din yang na-add na imaginary hydrogen. So madali lang kapag catalytic hydrogenation and skeletal yung given. Kasi i-erase lang natin. Erase lang natin yung double bond, yan na yung product. If it is catalytic hydrogenation. Kasi again, what are being added? If catalytic hydrogenation, hydrogen. And again, skeletal formula, imaginary man yung hydrogen. So you may not, no? Write the hydrogen being added. Kasi again, imaginary lang naman sila kapag skeletal formula. Okay, so that's it for catalytic hydrogenation. Okay, so example ng mga nakaskeletal number 2 and 4. Alam niyo na agad kung ano yung magiging product, no? If I write the chemical equation, add, so plus hydrogen gas, then nickel. So kopyahin niyo yung buong molecule. Kopyahin niyo yung buong molecule. Okay? Then 'di ba dito mangyayari yung hydrogenation. Hydrogenation. After you break the pi bond, erase the pi bond, addition of hydrogen can now be facilitated. But again, nakaskeletal man ito. So meaning, yung pag-add natin ng hydrogen, imaginary lang. Kasi skeletal. So pwedeng ito na yung final product. Okay? Ganoon din kapag yung number 4, skeletal din ito, di ba? Skeletal formula. So when I write its chemical equation, so plus hydrogen gas, then in the presence of platinum. Ganun din. Kopyahin nyo yung buong molecule. 1, 2, 3, 4. Then, dito ba? And then, merong methyl dito. Okay? So, yan na yung final product. You simply break the pi bond. Kapag skeletal, applicable lang yan yung pag-erase ng double bond. Then, yan na yung product. Kapag nakaskeletal, yung portion na kung saan makikita yung double bond. Pero kapag ganito, hindi man yan skeletal, 'di ba? Kung nasaan yung double bond, hindi naka-skeletal, naka-condensed. So yung gagawin nyo, mag-add ka lang. Add ka each. After you break the pi bond, do not forget that. Una talaga mangyayari, break the pi bond. Erase mo yung pi bond, then mag-add ka each ng hydrogen. Add ka each ng hydrogen. That's it for catalytic hydrogenation.